Okay, so we'll start with the queue now. 1 second. Stop sharing. Queue is first in, first out data structure. Queue can be implemented using arrays or pointers. Same disadvantage are associated with stack, hold true for queues. In addition, in the case of queues, whenever the element at the front is deleted, all elements are to be moved one position forward, which leads to time overhead. Else, there will be a waste of memory. With the help of pointers, these disadvantages can be overcome. There are two important operations associated with the queue. They are add and delete. An add operation will be will add an element to the end or rear of the queue. A delete operation will delete an element from the front of the queue. Uh, One simple way to understand these operations is to remember that the order of deletion, the elements from the queue will be exactly same as the order of addition of elements to the queue. You can draw an analogy for of the queue data structure to the people standing in the queue for entering a bus. Whoever is at the front will get the opportunity to enter the bus first. Any person who is not in the queue intends to enter the bus should stand in the queue at the rear last. Just 1 second. Hello.
Hi.
Can you hear me?
Yes.
Yeah. Okay. So let's continue. So I've started with the queue basically. Just 1 second. Okay. So one simple way to understand this operation is to remember the order of deletion of elements from the queue will be exactly the same as the order of addition of the elements in the queue. The elements are added. Let's see. First in, first out. Add an element to the rear of the queue. So addition will happen at the bottom, at the rear. And I think removal will happen from the front, correct?
Yeah.
Okay. Uh, so we're discussing queues. You can draw an analogy of a queue data structure to the people standing in a queue for entering a bus, etc. Whoever is at the front will get the opportunity to enter the bus. Any person who is not in the queue and intend to enter the bus should stand in the queue at the rear. A DQ is a special exam question as a DQ is a special form of queue in which addition or deletion of the element is possible to be done at the front as well as at the rear. Did you read about DQ? Is it a like? Is it the same? You already knew about it. I thought DQ is an operation,
Yes.
a
It
special
was
form
there
of
in
queue.
the chapter on cues.
Okay, special form of queue which will addition deletion elements possible at the front as well as at the rear. So concept of first in first out does not hold in DQ. I think that's the difference between DQ and Q. That the concept of FIFO does not hold here. More information on queues refer to this. Write a program in C to implement a DQ using arrays. All operations associated with DQ are to be implemented, which means, I guess, push and pop. So, program in C to implement DQ. Okay, in this article, we are going to learn how to create an input and output restricted DQ with the help of array and data structure. This differs from the queue abstract data type first in first out. So first in first out will not apply, where elements can only be added to the one end, removed from the other. An input restricted DQ, so that's one type, and output restricted DQ. So input restricted DQ is one where deletion can be made from both ends, but insertion can only be made from one end. Okay. So because it's input restricted, that's why the insertion can only happen at one end, but the deletion can happen from both end. And I think in this one is output will happen only from one end, but input can happen from both the ends. So this is input restricted DQ, insert, delete, delete. So delete can happen from both ends. Insertion can happen only at one end, let's say front. And here deletion happens at the rear, and insertion can happen at both ends. Okay. The below code consists of many functions. Four functions are general, two display functions, two special and main functions. Implementation starts with main function and then user chooses input or output of restricted queues. According to the choice, one of the two special functions get invoked and that function leads the way. As above explained a little about the operational rules of both types, the user gets the option to operate. There are four functions. I think that's why they're saying that uh, do all the operation associated with the DQ. So four functions: insert left, insert right, delete left, delete right. As the name specify, these functions add or delete to the corresponding sites. Then we got two display functions for both different types of the queues. Size of the array is 5 by default. To change or edit the second line of the code. Okay, so I think they're setting the maximum to 5, and okay, so that's your DQ array of size 5. Left they're setting to -1, right they're setting to -1 initially. begin of the insertion. So what I'm doing here, it's quite big actually. My God. Okay, input restricted DQ, output restricted DQ, enter your choice. Let's say you want to input in the queue. Okay, so if he chooses one, then we'll treat it as input restricted DQ. I guess we should do only one for now. Don't want to like make the program really, really big. One concept is understood, then we can accordingly do the other one. Okay, so input restricted will call this function if he chooses that. Okay, so then again we'll ask him insert at the right or delete from the left, or delete from the right, or display or quit or enter your choice. This looks good, you know. This is what I was talking about, that kind of an interactive program which lets the user insert, and that way we can throw him all sort of error messages that it's full, it's empty, whatever. So we take the choice. If it says insert right, then we call that function. Where is insert right? Yeah, this is insert right. Okay. Int added item. Okay, if left equals 0 and right equals max minus 1, or left equals right plus 1, then queue overflow, which means there are no elements left to enter more. If left equals minus 1, if the queue is initially empty, then left equals 0, right equals 0. Else, if right equals max minus 1, right is at the last position of the queue, and right equals 0, else right equals right plus 1. Input the elements for adding in the queue, and this will be added item. And dq right equals added item. So I think we should try this. Why is it showing like that? So string operation, stack operation. Now we'll do queue operations. 5 queue operations. I think I put that there. I can't drop it. Move. Okay, this is what? DQ. Okay, so let's start. Oh, it was quite big. Okay, we define max size of the array, basically. You can call it size or call it max, whatever. Define a constant max equals 5, and then int dq array size will be max. And then left, if we initialize it to -1 and right to -1. Left equals -1, int right equals -1. Then we'll directly go into the main. Void main, return 0, not returning 0. Int choice. Okay, so we print input restricted DQ, output restricted DQ, DQ.
Why do we have to do input restricted or output restricted? We can just make it unrestricted.
Just do one, you mean?
Just make it unrestricted, like you can do addition deletion from both ends.
There are two types they're saying, right?
Yeah, but it's not mentioned in the question.
Let me see. In the book, is it talking about these two types?
I
Can
don't
you can
think
you
so.
check the book? No.
Yeah,
So what
I'll
is the
check.
definition of the DQ according to book?
I think it was just addition and deletion can be done from both ends, but I'll check again.
Both ends. Okay, then that's fine. Then we won't create two. We won't create any choices basically in that case. Okay. So I guess we can write this directly there. We don't even have to create a function for that. We can do this over here. Insert, delete. So of course we need the choice. We'll do insert at right, delete from left, delete from right. I think we have to have insert from left also here.
Yeah.
And same thing for delete.
In the book, they don't have the two types.
You mean
I'll
the
check.
you confirmed it, right? Okay, good.
Yeah.
So this will be choice 2, choice 3, choice 4. Which will be delete, delete. Okay. Display and quit. Display and quit. Enter your choice, and then we take the choice from the user. Scanf, percentage D, and choice. Okay. Then we use a switch statement. Use a choice. Case 1. Case 1 we want to call insert right. Of course we have to create those functions, we'll do that in a moment. Break, and then we have it like, I think we missed here 5 and 6. Insert left, break, is P, so delete, left, delete right, is 4, delete left, and of course we have to break it. Break is 5. It was display queue, and the last one was just quit, was just break. Yeah, and then if he chooses anything else, then we show him a message saying that you entered wrong choice. Incorrect choice entered. Oops. Okay, and then while choice is not equal to 5, we just loop through this. While, oops, choice is not equal to 5, keep looping through this. Okay, now we have to create these functions basically. We start with the insert right on top. So void insert item, if left equals 0 and right equals max minus 1, or left equals right plus 1, overflow. 0 and right equals max minus 1, or left equals right plus 1, then print queue overflow and then return. That means queue is full. If left is minus 1, which means queue is empty, then set the left and right to 0. Why are we setting right to 0 in this case? Sorry, left to 0. He's just inserting an element on the right.
I think because left equals -1 is used to check if the queue is empty.
Hmm. Right. Queue, if the queue is empty, set the both left and right to 0 because we are adding a new item. And here queue is full. Full. Okay, so we set the left and right to 0. Left equals 0, right equals 0. And then if right equals max minus 1, which means right is at the last position of the queue, so set the right equals 0 to go in the else. Then right equals 0. Now, why are they setting the right equals 0 if it's max minus 1? If right is max minus 1, which means right is at the end already.
Is it circular?
No. Here they're already checking that information. Not sure why they're doing that. We'll see. Then right equals right plus 1. So that is correct. Let's say is on the let's say is on the seventh one, like the current position is 7, index 7. We increment that becomes 8. Was inserting from the right. Then we print it, input the element for adding the queue, scanf, we take the item. I'm just calling it item, not added item. So whatever the position based this condition is at that point of time, we're setting the DQ array at that position to that item that the user has entered. Um, what I want to do is I want to do display after this because I want to see if at least this much of program is working correctly. So I'll do display. Display queue. Void display queue. If in front position equals left and rear position equals right. Left equals -1, queue is empty. We already know if that. And then return. And if front position is less than equal to rear position, okay, first we have to print this. If front position is less than equal to rear position, while front position is less than equal to rear position, just display all of those. Okay, and then front position plus plus, right? Else you have to do a while loop there. Okay, else while front position is less than equal to max minus 1, dq front position. Okay, so what are the different condition is checking? Um, is checking that if this value is less than equal to this, and here is checking if it's less than equal to max minus 1.
It looks like it's circular.
It's circular. So dq can be
Yeah,
circular.
because uh, they're implementing it like that.
Okay.
So if the front position is more than the rear,
Hmm.
then they're going from front to max, and then going to zero, then zero to rear.
So here they are going up until the end, right? They'll go
Yes.
up until the rear basically. And here they are going till the end of the queue. So this is, I think, they're treating that the queue is full because that's when max minus one.
Yeah.
Sorry, this is yeah. So if it's less than max minus one, okay. And this is like maybe rear is somewhere in the middle. So at this position, perhaps the queue is not full, right? Okay. So let's do the second one. So if that's not the case, then we do else. I'll copy paste this and change it. While front position is less than equal to max minus 1, dq front position, again front position plus plus, and over here they are setting the front position to 0 after that. And why are they doing that? Why are they setting the front position to 0 and again looping through. Let me see if they explained anywhere. No. Okay. We'll write that and we'll see how that is going. We'll probably get a better understanding. So I guess that's what's happening there. And then finally outside that, just printing the next line. So let's see. Let's try to run this program. Let's see if it's all working fine. Oh my god. What's that? What is wrong here? Can you see what's wrong?
There shouldn't be a semicolon for hash define.
Okay. Now, uh, in function insert right, L value required as left operand of the assignment. Okay. Um, Implicit declaration of the function insert left. Did you mean insert right? Oh, I didn't declare these functions, right? Okay, so I have to declare it. What are the functions? Insert left, insert delete right, delete left, delete, delete right, display queue. Now what? Line 104. Expected a while before this. Do while see. Is it that? No. So do. Oh yeah, there's
Yeah,
one
there are too
missing here
many.
because one is for do. And this one is for switch basically, and this one is for do while. It should be in the same line as this one. And then this one, there's still something wrong. So switch, close it. This is fine. Do while, close it. There's one extra, or what?
Yes, I think the last one.
Permission denied. Cannot open.
Maybe you have to do int main return 0.
What's wrong?
Try putting return 0 at the end.
No, it's giving stupid errors. Where is the button to run go? Over here. My God. I'll push it. Try it at your end.
Okay.
Check out DQ. Okay. I'll stop share. Let's just make that work and then we'll call it a night and then we'll do this tomorrow.
Okay. Should I do git reset?
What branch are you on? Yeah, just do git reset hard because your code is anyways pushed and merged. You have to do git fetch all before you can check out to that branch. Hyphen all. Now it'll list down that branch. Copy that branch name and check out to that.
This branch.
First one.
Now should I do pull?
Yeah, git pull origin and the branch name. Just try to run that if it's working for you. Also run on the program compiler online also while this is running. Showing you the errors but not to me. Surprising.
You already fixed these errors.
No, no, like in your editor is showing underline, right? For me, it
Yeah.
wasn't.
Mm.
There's still a problem here. Can you see? At 98. I think it doesn't have the. I didn't save it, I guess. Hold on, I'll give it to you. Those functions are not defined, right?
Yeah, but those are just warnings. It should still run.
Okay.
I have changed these VS Code files for it to run.
Hmm.
So It's not running.
I shared a link with you. Copy the code and try in that online compiler. It gives you error also and it's faster.
Okay.
Saw the error.
It's
Why is it
showing
saying
this
undefined
error.
reference? But why is that?
Uh, the
It's
functions are
saying,
not defined.
but I put the functions below the. Let me give you in the chat. Don't type it like manually. Take time. Send you in the chat. I don't understand why it's doing that when I already declaring it on top.
It's still showing that.
Mm, is it the semicolon that's causing the issue? Yeah, I think it's a semicolon. Remove the semicolon and try.
Wait, semicolon.
One at the end of the insert left, insert right, line 72 to 75.
That has to be there, I think. You're declaring.
Remove it and see. And remove the display queue function because we already have that multiple times.
Now it's saying expected semicolon.
Oh my God. Fine, let's not worry about it today. Uh, we'll deal with this tomorrow.
Okay.
Okay. All right then. Good night. And tomorrow will be 8 p.m. Okay.
Okay.
Okay. Bye.
Bye.